Okay, sorry the video was cut short. We have the time, that is 4 seconds. Um, yeah, this video is basically a continuation of the previous one. If you go to the latest videos, you'll find that the one before is what started this one. So, yeah, the distance is what we're looking for. Gravitational acceleration of the projectile going up is negative 9.8 meters per second squared. I can't really say that this is the time going up, since I'm not sure if the height is the same, is as tall as whatever this is, the t. So for VF, we do know it. It's 0. So let's try this formula. Let's see if the other formula is also usable. We don't know what the VI is. We have to look for VI first. So negative 9.8 times 4 is basically 19.6 times 2. It is 39.2. Okay, so cancel the negatives. The answer is 39.2. Well, that's not the final answer yet, but it's going to help us in finding the actual answer. So exactly how high up did the ball go? I suppose, regardless of the time, the initial velocity will still be the same. Yeah, it makes sense if you think about it. Let's look for the distance. Distance, VIT plus GT raised to 2 over 2. Or let's try this one. Either way, let's use this instead. VI 39.2. Okay, so given that the time is 4 seconds, we have to look for the distance. So this one we're not, I don't think we have to find this. It's not in the question. We're just being asked how high the ball is after 4 seconds, wherein it is said to have landed right next to the T. So gravitational acceleration is negative 9.8. Time is 4 seconds again. Divide by 2. So 156.8. We have negative 78.4. 156.8 minus 78.4 is equal to, well, I'll be damned. It's 78.42. didn't know 156.8. Oh yeah, it makes sense. I'll be damned. That's not the answer. Where did I go wrong? Maybe this is not the distance yet. I'm thinking that the t is somewhere here, and the distance, the actual distance is, I suppose, a lot higher. We have to look for the time. But how? That's it. I kinda give up. Okay, it was the same process. You had to look for VI. It is said to be 19.6. Time is 25. How did 25 wasn't given? How were we supposed to know that information? It is stated here. Well, where the heck do we have to find that? Yeah, something's wrong. Okay. I suppose I've never answered this before. I'm actually surprised. Why didn't I have notes on this kind of question? No, no, no. I remember. I remember solving this before. I'm just not sure where it is. Found it. I think. I'm not so far. This is what I just answered. Wait a minute. Did they make a video about this before? It's kind of weird. Yes, yes. This is the solution. What is a T? Dude, that is so... What is a T in golf? Oh, never mind. I'm sorry. Uh, I guess you should also be culturally educated. I didn't know what a T was. I thought it was something like... I initially actually thought that um, there was a mistake in the spelling. I thought it was tree. But then, yeah. Anyways. Let bygones be bygones. Let's put a T here. Okay, now it makes more sense. So 4.0 seconds, it lands right next to the T. So this is what we consider as the time total. But the time going up, as long as I know, no, I know the principle. So let's say this is the surface. Let's assume that it's even. It's an even surface. So the time going up is equal to the time going down if the surface is even. But then let's say if there's a projectile and it's fired from a cliff has a considerable height, then the time going up is not equal to the time going down. In theory, if you think about it, it takes a little longer for the projectile or for the object to land if the object is fired from a cliff, say a cannon or something. So, from that, let's say that the time going up is equal to the time going down, which is equal to 2 seconds. Since you have 4 into 2 parts, you get 2. Okay, so now that we have that information, we have to compute for the distance. But VI is missing. Let's look for VI first. Okay, so this gravity VF is 0. VI is missing. Time total is 4 seconds. Again, 9.8 times 4 is 39.2. Don't forget the negative sign. So what is the square root of 39.2? It is said to be 6.26099 and then meters per second. So how high up? We're looking for the distance. D is equal to VI t plus GT raised to 2 over 2. What is the time? We're only looking for the distance going up, not the total distance. So I'm thinking we should use the time as 2 seconds instead of 4. Either way, just like what I said a while ago, the VI is still the same. So G is negative 9.8. Need more space. Time is 2 seconds. Hmm, that's funny. Uh, we have a negative value. What is RVI? Mm, yeah, the time has to be the time going up. Awesome. So 2 times 9.8 is 19.6. Why did I find the need to place a radical sign? Because again, the unit has raised to 2. It just doesn't feel right to disregard it. Just write it as meter over second without any um, process that proves that um, it moved from here to here. If you um, change something, there has to be a reason for it. You can't just leave it as it is. But right now, I'm not really sure how to prove its correctness. Even though we all know that the unit for VI and VF, they're basically the same, they're meter per second. But yeah. Well, sorry about that. Lesson learned. If you're computing for VF or VI, the time should always be either going up or going down. So the answer for distance is said to be 19.6. Weird. I'm not sure if it's a coincidence for the distance value to be also the same value as, well, not the one with the units, but the number itself is the same. Crazy. But anyways, you got it. Let's move on to the next. Okay, so case 2 is a projectile fired at an angle. I'm not sure what case 1 is, but I suppose it has something to do with a ball or any projectile being thrown upwards. Let's start with number 1. A deer leaps off of the ground with an initial velocity of 5.5 meters per second. Uh, Angle is equal to 20 degrees. Then lands back on the ground. X and Y components. Jeez, I forgot now. I forgot how to compute. Okay, so let's identify first the given. So we have V, let's organize it in a table. So going up, the final velocity will always be 0. Going down, the final velocity will be at its maximum. So 5.5 here, this is the maximum going up. Vi, once it goes down, it becomes 0. aside from that, we have to compute for the gravitational. No, no, no. It's already a given. Going up, the gravity is negative 9.8 meters per second. The gravity going down is positive of the same thing. Uh, G distance. Essentially, distance going up and going down, they're the same as long as the surface is even. Although in God's perfect world, uh, distance, the surface can never usually be even. Uh, Learning about the basics in physics, uh, I can't really say more about it, but yeah, we're just learning the basics. We know that it's not really realistic to think that the surface is even, but yeah, all good. Um, I'm thinking that in engineering, as long as the surface is relatively even, it can never be a perfect even, but if it's just, yeah, I suppose there's a measure for that. If the angle of elevation is um, negligible in a way, then yeah, the calculations can never be perfect or perfectly accurate, but yeah, it does um, do the job. Anyways, what is the angle of 20 degrees? How do we write that? Oh, sorry. Wait, where are we? Hmm, not complete. Hmm, found it. Okay, so hmm, we do have to memorize two more formulas, Vix and Viy. So those are basically the x and y components. How do I write it? Vix is equal to um, sine or cosine. If you think about it, it's the x-axis. So let me guess, it's sine. Something sine. Wait, just kidding. It's actually cosine. Okay. So from there, uh, we don't know the distance and the time. We'll leave it blank for now. But in the meantime, let's look for the x and y components. Vix is equal to Vi. Uh, hmm, for a while. Yeah. I'm not sure why we don't use the Vi going down. It's always the Vi going up that we use. I am yet to know the reason why. So what does Mr. Calculator say? 5.5 cosine 20, 5.16831 degrees. Is it in degrees? No, just kidding. It's meters per second. My schema is getting rusty in this lesson. Okay, so these are the x and y components. 5.16 and 1.88. Okay, good. Yeah, I think this is another formula. It's not exactly a formula, but it's important to know that Vix is equal to Vx. I'm not sure what's the limit for that. Like, for instance, in what scenarios is it applicable in? Okay, so what was the total time the deer spends in the air? So in other words, time total is missing. So how do we solve based on what we have right now? Let's try yeah, let's look for the time going up. Since it's equal to the time going down, we'll just multiply our answer by 2. That we're going to do that because we don't know what the VF is going down. So yeah, let's just stick to what we have. VF going up is 0 meters per second. VI going up is 5.5 meters per second. Divided by the time going up, which we don't know. So time going up is equal to negative 55 meters per second, negative 5.5 meters per second divided by 9.8. Why do we keep forgetting writing the units? So we have 0.56122 seconds. Sorry, that's not the final answer yet. I keep forgetting. Just multiply. I hope you don't. I hope you haven't closed your calculator yet. Just multiply it by 2. You get the answer is 1.12245, or basically 1.12 seconds. Okay, so far so good. Let's just see if I'm correct. Okay, something's wrong. Okay, so apparently there's a difference between VI and VIY. For some reason, we don't use VI anymore. What we started with. What the heck is wrong with this? Yeah, it's lagging. When am I getting a new unit? Okay, so a while ago we computed for the two. Let's just focus on the VIY. Um, what is our VFY? Still 0. Okay. Makes sense. Okay, so where do we put VI? I almost forgot that principle too. Um, it this particular principle states that VIY going up is equal to the VIY going down. Also, as long as the surface is even. And so, what is the VFY? Still the same. Yeah. Is it? I'm not confident with my own input. Nope. VFY going up is actually 0. I don't know what I'm talking about. Okay, so we have 1.19195 seconds. Multiply that by 2, we get 0.3839. Okay. I'll be ending with letter C. I'll just continue this later. I can't believe we're just halfway. Maybe I'm just really slow in computing. What is the total horizontal displacement of the deer? I think this is the Vx. I think. Is it? Yeah, it's the Vx. It's a good thing I remember. It's been a month since I've reviewed this lesson. Shoot, what is this? It's from calculus. Dx over time total. Okay. Feels like I have dementia. Or maybe all of my brain cells are still not They still haven't moved on from the DCAT. I don't know. What is your total horizontal displacement? Okay, what is the dx? Dx, I suppose, is the total distance. Is it? Oh, wait. Never mind. I have to label each variable. So dx is actually the total horizontal displacement. What is the vx? What is the t? Well, t is already known as the total time, so I won't write it anymore. What is vx though? I think we computed for that a while ago. I think it's equal to vix. Well, yes. Vix is 5.16, 16831. What is the time total? We just solved for it a while ago. It's 0.3839 seconds. So the answer is 1.98411 meters. I think the horizontal, by the word horizontal, oh wait, is it this or is this? Ah, yes. The total horizontal displacement is like the entire journey. Like, wait, I'm not supposed to say that. It's kind of sensitive. I might mess up the definition of displacement with distance, since one is scalar, one is vector. One point 9836. Yeah. I'm not sure why my computation is kind of far from his, but it's still 1.98 essentially. Oh wait. Uh, this is the x component of the initial velocity of the deer. Makes sense, I guess. Yeah, that's it for this video. Kinda tired. Thanks for watching, and there will be a next one.